Hello students, today we'll continue with the remaining portions of the chapter Inverse Trigonometric Function. In our last class, we discussed the basic fundamental concept of inverse trigonometric function. Today, we will do the inverse trigonometric functions. We'll do the properties in the form of theorems of inverse trigonometric function. The first property in the form of theorem, theorem 1, which says, which is also known as self-adjustment property. It says sine inverse of sine theta equals to theta. What is this theta? This theta belongs to the principal domain for the sine inverse. Or I can write this as sine inverse of x equals to x. What is the domain for sine inverse? Your x belongs to minus 1 to 1. Similarly, we'll have the self-adjustment property for cos and tan also. Like this. Cos inverse of cos theta equals to theta. Theta belongs to 0 to pi. Cos of cos inverse of x equals to x. X belongs to minus 1 to 1. And tan inverse tan theta equals to theta. Theta belongs to minus pi by 2 to pi by 2. Tan of tan inverse x equals to x. X belongs to r. This is possible only because for this restricted domain and the range, sine inverse functions, cos inverse functions and tan inverse functions do exist. Now, before moving forward, let's do one or two illustrative sums. The first one, asking you to evaluate the value of sine inverse sine pi by 3. How do we do this? Now, you can check this pi by 3. What is this pi by 3? This pi by 3 clearly is between minus pi by 2 to pi by 2. So, I can directly write sine inverse sine of pi by 3 equals to pi by 3. That's my answer. Right? What about this one? Cos inverse cos 9 pi by 8. Here, your 9 pi by 8 is not belonging to the principal domain of cos, that is 0 to pi. So what to do? Now, can I write this cos 9 pi by 8 as cos of 2 pi minus 7 pi by 8? 8 to 16, 16 minus 7 is 9 pi by 8, right? And I apply the property here. 2 pi means even multiple of pi by 2, plus and minus acute angle, cos with the acute angle, plus and minus sine as per the quadrant rule. This is the fourth quadrant, 2 pi minus something, fourth quadrant, so it will appear as the plus sign. So this means cos pi by 8 is same as cos 7 pi by 8. So I can rewrite this as cos inverse cos of 7 pi by 8. Here 7 pi by 8 is between 0 to pi. So I can write directly this is equals to 7 pi by 8 this time. Done? One more. Now here you have been asked to prove something. It says sec square of tan inverse 2 plus cosec square of sec square of tan inverse 2 plus cosec square of cot inverse 3 equals to 15. Let's see how to do this. Now this is sec square theta, this is cosec square theta. What do I do? Sec square is 1 plus tan square. For this tan, this whole thing is theta. Cosec square is 1 plus cot square. Of course, I am starting with the left hand side. Cot square, cot inverse 3. Now, this is 1 plus 1 is 2. And now, can I write like this? Because this is the whole square. Plus cot of cot inverse 3 whole square. So, tan of tan inverse of 2 will give you 2 square. Cot of cot inverse of 3 will give you 3 square. 2 plus 4 plus 9 This is 6 plus 9, 15. Proved. Which is your right hand side. Hence proof.